Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for previous NEET questions from the chapter Electromagnetic induction. Let us start with the first question. A uniform magnetic field is restricted within a region of radius small r. So radius small r means in the first loop up to here. The magnetic field changes with time at a rate of dB by dt. Loop 1 of radius capital R, which is greater than small r, encloses the region small r, and loop 2 of radius capital R is outside the region of magnetic field as shown in the figure. So then the EMF generated is, so you have to pick out which option is correct. So first you get back EMF formula. EMF is equal to minus d pi by dt. Separately, pi is nothing but flux, d by dt. So therefore, pi can also be written as v into e. Actually, this is an example of dot product between two vectors. For the present question, so application of dot product is not required. So A is area. So area of this particular region. So therefore, it is going to be area writing as pi r square dB by dt. So therefore, since magnetic field is restricted to smaller, so therefore there is a chance for EMF to get generated in loop 1. So whereas there is no magnetic field in loop 2, so therefore EMF does not generate in loop 2. So the answer is EMF get generated in loop 1 up to small r only, whereas EMF generated is 0 because there is no magnetic field. So the reason for the generation of EMF is change in the flux. So d pi by dt with pi r square in loop 1, whereas EMF 0 in loop 2. So fourth option is correct. Moving to the next question. A long solenoid of diameter 0.1 meters has 2 into 10 to the power of 4 turns per meter. At the center of the solenoid, a coil of 100 turns of radius and radius 0.01 is placed. So at the center of the solenoid, there is another solenoid. There is a coil, there is a coil placed. So coil radius 0.01 meters placed with its axis coinciding with the solenoid axis. The current in the solenoid reduces at a constant rate, 0 amperes to 4 amperes in 0.05 seconds. If the resistance of the coil is 10 pi square ohm, so we need to find out the total charge. So first, because looking the physical quantities values given, so we need to write EMF is equal to minus d pi by dt first. Even pi is the flux. Flux can be written as B into A. And okay, since they mentioned number of turns also, there is N. So the more number of turns are given, so more will be the EMF. So therefore, altogether, what you can say is N into A with the dB by dt. So even you can extend this as N into A B2 minus B1 by dt. So other side, EMF is numerically equal to potential difference. So making use of Ohm's law, I into R. So minus NA. So let us write NA as pi r square because per meter. So number of turns per meter. Then even B2, B1 is anyhow 0 because you can separate the right. B1 is equal to mu naught Ni. So I is 0 in the first case. So therefore B1 will be 0. B2, that too, the small n is number of turns per length. So since current is 0, the entire quantity becomes 0. Now mu naught Ni. So number of turns per length. Therefore, this is going to be 4 pi. So here, what you can adjust is this B2 will continue in the equation. Then divided by dt. Let us write minus n pi r square. Then with B2 mu naught N I2 because I1 is 0 divided by dt. So now from the idea of current electricity, I can be written as dq by dt, rate of flow of charge through any cross section, minus n pi r square with mu naught N I2 divided by dt. So therefore you can cancel. Sorry, I forgot to write r. So there is r also. Dt get cancelled. Now let us continue further. So dq are looking for minus n pi r square mu naught N I2 divided by r. So now let us substitute the values. N is 100 turns. Pi, just you continue, right? So this is diameter has these many turns. So therefore, N is the coil which you are placing is 100 turns. This is for the case of solenoid, number of turns. So pi will continue r square. So therefore, this is going to be r square. R is 0.01. So 0.01 squaring it. Squaring it means you will get 1 into 10 to the power of minus 4. Then mu naught is going to be 4 pi into 10 to the power of minus 7. Number of turns for the case of solenoid, it is going to be 2 into 10 to the power of 4. I2 is 4 divided by r. So r is a 10 pi square. So you can cancel this pi pi square. Now, so 100. So there is 100 means, so this is going to be 10 to the power of plus 4, 10 to the power of minus 4 get cancelled. 1 0 get cancelled. And next time. After this, so this is going to be minus 1. 4 2s are 8. 8 4s are 32. 32 into 10 to the power of minus 6. So minus 6 can also be written as a microcoulomb. So you are looking for charge. So second option is correct. Moving to the next question. The magnetic potential energy stored in a certain inductor, 25 millijoule, when the current in the inductor is 60 milliamperes. So this inductor is of the inductance. So we need to find out inductance. So magnetic energy stored, magnetic potential energy stored in the inductor is half energy stored, half Li square. So E mentioned, energy mentioned. So this is 25 millijoules. So directly you can add minus 3. Half into L you are looking for. I is also mentioned, 60 square. So it will be 60 into 10 to the power of minus 3 whole square. So therefore, 3600 into 10 to the power of minus 6. So this is going to be this minus 3 get cancelled. Then you can even cancel 1, 2. So there will be minus 1. You will be retained with minus 1. This is going to be 50. 2 into 25, 50. Divided by 36. And there is minus 1. If you take minus 1 up, so there is 10 plus. So 50 by 36. 50 by 36. Roughly, just you start cancelling with 4 into 12.5 is this is 4 nines. Then again, this is 125. 125 by 9. So this is going to be 9 ones. 3 left. 9 3s are 27. 8 left. Almost 9 nines are. So therefore 13.9 roughly. 13.9 Henry. Unit of inductance is Henry. So last option is correct. Moving to the next question. A 800 turn coil of effective area 0.05 square meter is kept perpendicular to magnetic field 5 into 10 to the power of minus 5. So when the plane of the coil is rotated, plane of the coil rotated to the field means, so cos theta, so n will be, normal will be parallel to the field. So therefore around any of its coplanar axis in 0.1 seconds, EMF. So once again, the same formula, minus d pi by dt. So separately writing d pi as B into A. Then next time. This is the field. So there will be also cos theta here. Remember, so since rotated through an angle 90, so therefore this B and A will remain constant. That too N also will be there because more number of turns of the coil, more will be EMF generated. Then cos theta 1 minus cos theta 2. Because there is minus outside, first you will get cos theta 2 minus cos theta 1, but taking minus inside, so this is dt. So coil is now initially is perpendicular. Effective area is perpendicular. So therefore the normal will be parallel to the field. So therefore initially you need to consider. Finally it is rotated through 90 means normal will be perpendicular to the field. Normal will be perpendicular to the field means theta will be 90. So theta will be 90 means this theta 2 does not exist. So N, how much is N? 800. How much is B? 5 into 10 to the power of minus 2. How much is area? Area is 0.05. So it is area only. Sometimes you may get radius also, making as pi r square. Theta 1, cos theta 1, cos theta 1 is, cos theta 1 is 0. So therefore, cos 0 is 1. Divided by dt. What is dt in 0.1 seconds? So this is going to be EMF. Now, so if you cancel this point and this point, you can cancel. This is 25. 25 into 8, 200. And there are two more zeros, which is 10 to the power of minus 2. 1, 2. So therefore, there is squaring. There is a minus 5 here. Magnetic field of this is not minus 2, this is minus 5. Therefore, this is going to be minus 5. 1, 2, 3, 4. 4, even 5. So it is going to be 0. 1 second, let me check. This is 0.05. Yeah. So there will be one more point here. So altogether, this is 0.1. Let me multiply. So finally, you'll get the answer 0.02 volts. Yeah. So there are 6 zeros. Divided by 6 zeros. So this will be minus 6. So one more point gets shifted left side of 2. So altogether answer will be 0.02 volts. Moving to, in which of the following devices the eddy current effect is not used? So it is an electrical meter. Most of the times, the device which is get operated due to the change in the flux, so eddy currents get generated. So we don't get any effect of eddy current in electric heater only. So induction furnace. So this is a particular device. We make use of change in the flux, which produces EMF. Even magnetic braking. This is one of the use of eddy currents. Even electromagnet also. So first option is correct. Moving to question number 6. Two conducting circular coils of radii R1 and R2 are placed in the same plane with their centers coinciding. Centers coinciding means this is one coil, this is the another coil. Say R1 is greater than, so it means this is R1, this is R. So the mutual inductance M between them will be directly proportional to. Suppose when current is flowing through, the first term, let us say there is a flow of current, flux linked to the second coil. If current is flowing through first, so this is the first one. So due to flow of current through this, so there might be induced current in the 2. So therefore, mutual inductance, this is going to be pi in B into A. So there is a magnetic field around the first one that is influencing the coil of R2, radius R2. So it is R2, A2. So this is the basic formula of flux. Pi 2 is equal to, get back the formula, mu naught. Since it is only one term, we can restrict that I by, this is going to be 2R1 into, so this is an application of Eisenstein principle. So this is going to be pi R2 square. So therefore, from the idea of inductance, pi is directly proportional to, otherwise pi is equal to Li. So therefore, L position is occupied by this quantity. Sorry, M, you need to write here M. So just to compare both the equations, excluding I, M position is occupied by this equation and this equation. So therefore, M is equal to mu naught by 2R1 with pi R2 square. So just M is directly proportional to R2 square by R1. So last option is correct. Moving to the next question. A square loop of side 1 meter and resistance 1 ohm is placed in a magnetic field of 0.5 seconds. The plane of the loop is perpendicular. The direction of the field. Again, normal will be parallel to the field. So therefore, theta will be 0. Direction of the magnetic field. So we need to find out flux. So get back the formula of flux, B into A, that to BA cos theta. So remember, theta is equal to 0. Just we need to write only B into A. Now, so how much is B? 0.5. Area of the square loop. So remember, area is L square. It is going to be 0.5. L is 1, L square will remain 1, 0.5 Weber. So unit of flux is Weber. Moving to the next question. A big circular coil of 1000 turn and average radius 10 meters is rotating about its horizontal diameter at 2 radian per second. If the vertical component of Earth's magnetic field at that place is 2 into 10 to the power of minus 5 Tesla, electrical resistance of the coil is 12.56. So we need to find out maximum induced current. So this is the particular question designed based on AC generator. So you might remember AC generator converts mechanical energy into electrical energy. So therefore, we need to take EMF is equal to once again d pi by dt. So you might know d by dt. Pi is once again number of terms mentioned NBA cos theta. So differentiation of cos theta will be minus d pi by dt cos theta. Along with this, there is NBA. So therefore, cos differentiation is minus sign. So again, differentiation of d theta. So therefore, cos differentiation is already there is minus sign. So minus sign omega t. So remember, omega is theta by t. So there will be omega. So with NBA. So when maximum EMF produced means the sign will be maximum, you will retain the equation as EMF as NBA omega. Now, so N is 1000. P is 2 into 10 to the power of 5, minus 5 in particular. Area. So radius mentioned area. So therefore, we can say that this is going to be pi r square. R is 10. R is 10 means R square will be 100. So last is omega. Omega is 2 radian per second. On the other side, we have EMF. So therefore, EMF can also be written as I into R because the question is current to find out. So 100 into 2 into 10 to the power of minus 5 into pi into 100 into 2 divided by. So bringing this R down. So writing the value of R as 12.56. So remember this is pi is 3.14. So 3.14 into 4 times will be 12.56. So this and this get cancelled. So 1 0 2 0 4 zeros. So therefore this is going to be minus 1. So it is 10 to the power of minus 1. Otherwise, yeah, here 5 zeros. This is 1000 turns. So there will be one more 0. Then 10 into 10 to the power plus 1, 2, 3, 4, 5. So all cancel. So therefore, then can we write like this also? It is 1 ampere. So first option is correct. Moving to the next question. I think this might be the law. Yeah. Question number 9. The magnetic flux linked to a circular coil of radius r is pi 2t square 4t 2t cube 4t square 2t plus 5 Weber. The magnitude of the induced EMF in the coil at t equal to 5 seconds. This is a simple question. We need to find out EMF. So once again, same formula. EMF is equal to minus d pi by dt. So differentiation of this particular equation. So minus d by dt. So directly 2t cube plus 4t square plus 2t plus 5. So differentiating. It will be 3 into 2t square because 3 minus 1. This is 2 into 4t because 2 minus 1 is 1 only. Plus 2 because it's a numerical value, fixed number, so no differentiation. So this is 60 square plus 80 plus 2 is equal. So substituting t equal to 5 seconds. 6 into 5, 5 square is 25 plus 8 into 5 plus 2. So this is 150, 150 plus 40, 190 plus 2. So it is 192 volts. So last option is correct. So moving to the last question. Yeah, already we have done one question based on this. The magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 amperes is. So we need to find out the energy, get back the formula. Energy stored in the inductor. E is equal to once again half Li square. E you are looking for. So in the previous question, they asked you to find out L. Now they are asking you to find out energy. Half into L is 4 Henry. So 4 microhenry in particular. I is mentioned to 2. So I square will become 4. So this is going to be 2 times. So answer is 8. 8 microjoule. So third option is. Thank you very much, students. In my next class, I'll continue explanation for the previous NEET questions from the chapter alternating currents. So don't forget to share and subscribe with your friends and relatives. Thank you very much.